We'll now look at a method for solving quadratics that's called completing the square. Whereas our zero product property can only be used whenever you can factor, our square root property can only be used whenever you have a term squared. Completing the square can be used on any quadratic equation. The first thing we want to do is rearrange the equation so that the constant is on the right. We need the constant to be on the right and all other terms to be on the left. The second step is to divide through by the coefficient of x squared. If there's anything other than a 1 in front of the x squared, we do need to divide everything by that term. The next thing we do is look at the coefficient of x. We're going to divide that number by 2 and then square the result. And this will give us a term that we need to add to both sides of the equation. Once we do this, we can then factor and then solve our equation using previous methods. Here's our first example, x squared plus 12x plus 1 equal to 0. The first step is to get the constant alone on both sides. Or on the right side, x squared plus 12x equal to -1. The second step is to then divide through by the coefficient of x squared. Here, that number is just 1, so we don't need to worry about that step. On this side, we're going to look at the coefficient of x, which is 12. We're going to divide by 2 and square the results. 12 divided by 2 is 6. Squared is 36. So this is the number that I'm going to add to both sides. X squared plus 12x plus 36 is equal to -1 plus 36. On the right, we can factor this. And this actually factors to x plus 6 squared. On the right, we get a 35. And now we can use our square root property. Taking the square root of both sides gives me that x plus 6 is equal to plus or minus the square root of 35. We can then subtract 6 from both sides to get that x is equal to -6 plus or minus the square root of 35. Our next one, 2x squared plus 5x minus 3. The first step, let's get the constant on the right-hand side. This gives us 2x squared plus 5x is equal to 3. This time, we have a coefficient in front of x squared, so we need to divide everything by 2. I now have x squared plus 5 over 2x is equal to 3 over 2. On the side, we take the coefficient in front of x, and we divide by 2, which is the same thing as multiplying by 1/2, and then we square. So this is 5 over 4 squared, which is 25 over 4. And this is the number we need to add to both sides. I now have x squared plus 5 over 2x plus 25 over 4 is equal to 3 over 2 plus 25 over 4. On the left-hand side, this will factor into x plus 5 over 4 squared. And it may not be immediately obvious that that's what this factors into. However, it's not hard to figure it out. The fact that we call this completing the square is because when we're done, we should have a perfect square on the left-hand side. In addition, the number that goes inside this parenthesis, you'll notice is the same number of when we first divided that coefficient in front of x squared by 2 before we did the square step. So we can find it like that. On the right-hand side, if I add these, I end up with 31 over 4. We can take the square root of both sides. I have x plus 5 over 4. On the right, I have plus or minus the square root of 31 over the square root of 4 is 2. We're going to move this up here. X plus 5 over 4 equal to plus or minus the square root of 31 over 2. I can then subtract 5 over 4 from both sides. And I end up with x is equal to negative 5 over 4 plus or minus the square root of 31 over 2. And if we want, we can rewrite this. We would get negative 5 plus or minus 2 squared of 31 over 4. And this is where I just found the common denominator and combined things. We'll do one last example. X squared plus 4x minus 7. Our first step, let's move 7 to the other side. We get x squared plus 4x is equal to 7. The number in front of x is 4. If I divide by 2 and square, 4 divided by 2 is 2, and 2 squared is 4. So I'll need to add 4 to both sides. X squared plus 4x plus 4 equal to 7 plus 4. On the left, this will factor to x plus 2 squared, and on the right, 7 plus 4 is 11. If I take the square root of both sides, I get that x plus 2 is equal to plus or minus the square root of 11. And then subtracting 2 gives me my result. X is negative 2 plus or minus the square root of 11.